Okay, let's keep going here. We know what we want the fraction class to be able to do. If I removed all of my comment delimiters here, I'd get red wavy lines all over the place because it doesn't know what fraction is. So we're going to write a fraction class. So let's go to our project menu up here and tell that we want to add a class. Choose class. And call it fraction. Class names are capitalized by convention. It's not a requirement. Okay, so here's my fraction class. So you need to have private data. An object is a combination of data and functions or methods that manipulate the data. So for a fraction, you need to have a numerator and a denominator. Those are really long variable names, and I'm just going to do a and b, and remember that a is the top number and b is the bottom number. So they need to be private. They're going to be integers. I'm going to call them a and b. Then I need to write a constructor, at least one. So fraction, and I better make that public. And if they don't pass in any arguments, then what I'm going to do is I'm going to set a equal to 0. I'm going to set b equal to 1. Okay. So that's my simplest constructor. And I'm also going to need a toString method. So let's do that before we do anything else. So we can check and see what our results are. So public toString. And I better say that this returns a string. And it's also going to ask me to put override in there, but I'll wait until it asks me to do that. So string. And all I want to do is return a string. Now I think that will work. If I didn't have the slash in there, the string, then I'd be doing a plus b, and it would do the addition and return an integer. But I think with the slash in there, it will automatically convert that to a string. If you wanted to be extra safe, we'll try it and see if it works in a minute. I think it will. If you want to be extra safe, you could put .toString after the a and .toString after the b, but I'm pretty sure that C# takes care of that for you. Okay. Now I'm getting a red wavy line here too that says, to make the current member override that implementation, add the override keyword. Now I think it overrides the default one anyway, but I'll put override in here. Okay. So now I should be able to go back to my main program, and I should be able to, okay, let's get rid of our comment delimiters here. And this is the line that I want to test. That's the default constructor. And all of the other stuff I don't really need right now. So I'm going to comment that out. And I'm going to do a write line. And if it writes 0 over 1, then we know that it's working. So let's go ahead and run this. And I guess it's not working. So let's choose, no, there's nothing to run. Unassigned use of local. Oh, I forgot to comment out this one. Now let's try it. Looking for 0 over 1, and it works. Now, just to show you or to refresh your memory about what happens if you don't have your own toString method in there, I'm going to comment that out. There is a default toString. Let's go ahead and run the program. But all it does is it tells you the type of the variable, and it tells you what the name of the program is or the project is that it's running right now. So that's not very useful at all. So you don't want to go with the default write line. So let's go back here and let's uncomment those lines. Let's write ourselves another constructor. So let's do public And in this instance, we will pass in an integer variable a, comma, and an integer variable b. Now we've got two a's and two b's. If I refer to a and b in here, I'm referring to the ones that were passed in. If I'm referring to these up here, I have to put this in front of them. So keyword this should turn blue. So this dot a equals a, which is the one that was passed in, and this dot b equals b, which is the one that was passed in. And there's a nice little feature here in the editor that selects the variable that you're talking about. So if I highlight a here, it shows me that this is a that is the same one. And if I highlight b here, it shows me that this is the same one. It doesn't do anything about these up here. If I highlight this a here, it tells me that that is the one up here, and I'm also referring to it here. And the same thing with b. If I select that, it tells me that this and this and this are all the same one. Now, only one of these constructors gets executed at a time, and the compiler figures out which one to call based on the signature. So the signature of this is fraction with no arguments. The signature of this is fraction with an integer and an integer for arguments. And this is where it might be a good idea to put three comment slashes there, and we get the documentation comment that comes up now, and we create a new fraction, and a is the numerator and b is the denominator. So now let's go back over to our main program, and let's uncomment this one. And it works now because there is a fraction constructor that is expecting two arguments. But what I want to do here is I want to back up, and I want to do the left parenthesis. And now it tells me that there are two fraction constructors. And the default one is one with no arguments, but this is the one with two arguments. Okay, and that's the one I want to do. So I'm going to type in 1, comma, and down below here. So this is the comment for the function at the top. This is the comment for the argument. So I said a was the numerator, b was the denominator. So, and then I'm going to do a right line. And I don't remember, did I uncomment that? I think I did. Yes, I still have the toString uncommented. So let's go ahead and run this one now. We should get 0 over 1 and 1 over 2. Okay, so it is working. Let's write another fraction constructor. I always want to put that extra a in there. And in this case, we'll just pass in one number. That's going to be our numerator. So this dot a equals a, and they didn't specify denominator, so that means they're passing in a whole number that we want to represent as a fraction. So this dot b is going to be the number 1. So let's do 3 slashes up here. We'll do the same. From a whole number. And the a is going to be the numerator. The denominator will be 1. And there's one more. There is the copy constructor where you pass in another fraction. And we need a name for this, and I'm just going to call it x. It's hard to come up with a meaningful name here. So what I want to do is x is going to have a numerator and denominator. I want to copy those into my local a and b. So this dot a is going to be equal to x dot a, and this dot b is going to be equal to x dot b. So I've just made a copy of the fraction x. So let's go back over to here. We can uncomment this now, and whoops. Then we should write it out. Then we're going to do this. We're going to make a new fraction for d out of the existing fraction a. So if I do a right line on d, I should get 1/2 because that's what a is. So our output should be 0 over 1, 1 over 2, 1 over 1, and 1 over 2. So let's go ahead and run it. Okay, that is C, I think, and yes. And then we write out A, which is 1/2. Then we write out B, which is 1 over 1. And then D, which is going to be a copy of A, is 1/2. So we've got 4 constructors. All 4 constructors are doing exactly what we want them to do. Now let's do an addition problem. Actually, let's do the multiplication first. That's a little bit easier. So it's going to return a fraction. And the name of it is times. I think I did lowercase. And I'm going to pass in another fraction. I'll call that other. Okay. What I want to do is I want to take the numerator of this fraction, this dot a, and I want to multiply it by the numerator of the other fraction. And this is going to return a fraction. So I'm going to create a new fraction. I don't want to change a. I don't want to change this. I want to create a new fraction. So let's see, fraction. So I'm going to create a result, and I better allocate some memory for it. Now I'll just use the default constructor there because I'm going to wipe out the numerator and denominator in a few microseconds anyway. And then I want to take result dot a equals, I spelled it wrong, and result dot b and then I need to return the fraction. You see I've still got a wavy line up here indicating that not all code paths return a value. Well, no code paths return a value because there's a single return statement in here. But I want to return the result. Okay. So let's go back over to our program here. And let's say, so I've used A, B, C. I've used all of those. Let's do this. Let's do D is already declared equals A dot times, and I'm going to multiply it by D, which is 1/2. So 1/2 times 1/2 is going to be 1/4. So if I go in and I write out D, which I've already done, so I'm going to copy that, paste it in. So I should get 1/4 as my last output value this time. Let's go ahead and run it. And I get 1/4. A is still the same. D would still be the same if I wasn't assigning it a value here. If I wanted to put C here instead, when I put in C, that's just the number 0. So if I put C there instead, and I write out C, and then I'll also write out A, which should be unchanged, and I'll write out D, which should also be unchanged. So this does not change the value, either the invoking object, which is A, or the object that was passed in, which is D. Neither one of those changes. Unless I put it on the left-hand side of an assignment statement, in which case it will change. So A and D should still be 1/2 and 1/2, but C should be 1/4. So our last output should be 1/4, 1/2, 1/2 for the last 3 lines. And it is. Okay, so we're up to about 15 or 16 minutes here. Let's stop this video and we'll continue with another video.